Hi everyone, we're going to go over some of the questions on the power exercise sheet, which is this one. And I'm just going to go through some of the hints or the ideas that might help you do the questions, but I'm not going to go through them in a lot of detail, because otherwise I'll take a lot of the fun away from it. If you get stuck on any of them and you can't do it even with the hints, then let me know and I'll run through them in more detail. Question 1a says there's a man digging a trench, converts energy at the rate of that much. So rate of energy is the idea for power. So they're telling you there that 1200 watts is the same thing as 1200 joules per second, and that's the amount of energy that the guy is releasing is consuming every second. And it says that he couldn't keep this up for very long because it's a lot of energy, but if he did keep it up for 8 hours, how much energy would it be? And then it's easy because you've got it per second, so you want to do it per 8 hours. You want to get the number of seconds in 8 hours, and that's easy peasy. They then say that the electrical energy is available at a cost of 10p per kilowatt, and they ask you to show that a kilowatt hour is equivalent to 3.6 megajoules. So again, they're asking you to convert from watts to joules, given that this is in hours and this energy here is in joules. So if it's 10p per kilowatt hour, well, it doesn't really matter if it's 10p in the first part. That would be in the second part where it matters. In the first part, they just want you to show that a kilowatt hour is equivalent to 3.6 megajoules. Okay, and kilowatt hour means it's power times time, right? So if they tell you something in kilowatt hours, it's the same thing they're giving you to you in power times time, and power times time is the same thing as energy, right? Because power is equal to energy over time, right? So if you multiply power times time, then you're left with energy. So that's why they're equating it to you to just megajoules. So they're telling you, show that one of these is the same thing as 3.6 million of these. Okay, and that's easily done because the 1 kilowatt hour means 1000 watts times 1 hour, and 1 hour is 60 seconds times 60 minutes, and so from there you should get 360 from here and then 1000 from there, and you get to 3.6 megajoules. This would be 3600, sorry. Okay, so that makes sense. And they ask you for the electrical cost equal to the work done by the man and discuss the result of your calculation. So I'll let you do that. The answers are on the sheet and should be able to do that, no problem. Question 2 says to write the units of these expressions in terms of base units. So what are base units? They're kilograms, meters, seconds, the most basic units of all. So work divided by time. See, this is question 2, no? Question 2, which we're going to do in another color for the fun of it. Work divided by time. Work divided by time. Okay, so what's work? Work is, the units of work is joules. The joules is not a base unit because it can be made up with more base units, more basic ones. Time is a base unit, so that's seconds, and that can't be chopped up at all, but work can. So what are the formulas that we have for work? Well, work is force times distance, and work is also just energy, which is joules, but joules we already have. So let's see if we can get force and distance in more base units. Distance is just meters, that's space. It cannot be brought any further down, but force can be. Force, the equation that we can use would be this one. It's the most famous one, and so that would be kilograms, which is a base unit, can't be reduced further, and acceleration is meters per second squared. So this is base, seconds we said was base, and kilograms is base. It can't be chopped up. Okay, but force is in newtons. So here we're saying that newtons can be brought up. A newton is the same thing as a kilogram meter per second squared, and a joule is the same thing as, well, we're going to look at it now, but all of that times distance times meters. Okay, so we need work divided by time. So from work, we can get it from force times distance, and force we have this one here, and distance is meters. So if we want to get work done, we need the force, which is kilogram meters per second squared, times the distance, which is meters, so we need to multiply this by meters again, and now we have work. So instead of putting it here, we can just put it here as meters squared, take it away from here. So now we have work, but we didn't want work, we wanted work divided by time. So in other words, we need another second, divide by seconds again. So if you want to do the final answer for work divided by time, then we need all of this divided by time again. So that would be another seconds on the negative. So if we divide by time, we need another second on the negative. So that would be kilograms meters squared seconds to the minus 3. Okay, whenever we divide by something, you have two options. For example, imagine you started with kilogram meters squared, and then you suddenly said, okay, let's divide this by seconds. Then you can put the seconds down here, or what's normally done in physics is you can put it at the top, but you put it to a negative power of 1, right? So if you start with this already and you come and you say, okay, we're going to divide this again by time, like we did here, except we had a 2 instead of a 1. We're going to divide it again by time, then you have two options. You can either put it down here and put seconds there, or since it doesn't make very much sense to mix the notation, here you're using minus, which means already over, and then suddenly you put something underneath. That mix doesn't make a lot of sense. So you have two options. You can either put it down there, which is not very useful or not very common in physics, or you can just say, okay, so the dividing in time just means to have another seconds at the bottom. So instead of 2 at the bottom, so that would mean, that actually means this, squared over second squared. That's what that means. It's a minus 2, so it's a positive 2 at the bottom. Instead of having that, I have 3, because I'm dividing by another second. So the seconds would come down here, multiplying at the bottom. It's the same thing as dividing. So that 3 just comes in here as a minus 3 when you divide by seconds. Okay. Hopefully that makes sense. That should be revision anyway, but hopefully that makes sense. Force times speed. So I'll let you do that one. You need it in base units. Force, we already looked at how you chop that up, and speed is already pretty much in base unit if you change it meters and seconds. So let's look at question 3. A motor drives a pulley which lifts a box of mass 5 kilograms at a steady speed of 2 meters per second. So there's a motor and there's a box with 5 kilos, and it's moving up at a speed of 2 meters per second, which is a constant speed, which is very, very important to understand that it's a constant speed. What is the power output of the motor? Power. So whenever they give us the speed of something and it's a constant speed and they ask us for the power, we're basically most likely being asked for the use of this formula, which is power is equal to force times velocity. Okay, and here we're given a box which is 5 kilograms and it's moving upwards with 2 meters per second of constant speed. It's very important, constant speed, and then they ask us for the power. Okay, so it's moving up. So what are the forces acting on this thing? There's that force which is moving it up, pulling it up with a pulley, and then there's this one which is mg. The mass is 5, so actually mg then just turns into 5g. Now, constant speed means that the forces up and the forces down are exactly the same, right? If there is a constant speed, that implies no acceleration. Therefore, all forces must be equal. Must be equal. So that means that the force that the rope is doing to pull this up is the same as the weight down. So in other words, when we put in the formula the power, what we want is the force that the that the motor is exerting, because that's the power they're asking us for. They say calculate the power output of the motor. So how much force is the motor doing? Well, exactly the same amount as the weight, because it's not accelerating, so it's the same force. So then we do the formula force times velocity. We have to use the force of the same as the weight. So then your power answer would be 5 times g, which is the force, times the velocity. And they give you the velocity, which is a constant 2, so you just multiply that by 2, and that would be 10g. Since g is 9.8, then that would be 98 watts, or joules per second. Okay, so I did that one for you. That should not have been too hard. Okay. So in question 4, you have, let's see, we can pull it up. Question 4, a piano of mass 300 kilograms is being lifted to a window 12 meters above the ground using a system of pulleys. So piano, 300 kilos, 12 meters above the ground. So we have a piano, 300 kilos, so the weight is 300 g, and it's being lifted up by a rope, and it's going to get to the top at the height of a window, which is 12 meters above the ground, using a system of pulleys and a diesel motor. They tell you that the motor has a power output of 800 watts, so the power of the motor output is 800 watts. So that's how many joules per second it can do of work. How long will it take to raise the piano to the window? So they're asking us for the time. Okay, so in order to get the time, we need to assume that it's gonna be at a constant speed. So I would write that down as one of my assume constant speed, because otherwise we wouldn't do the formula of force times velocity formula for the equal to the power. We can't do it without that. So assume constant velocity, and we know that this is 12 meters. So if we find the velocity, we know that we can use the velocity is equal to distance divided by time. So we can rearrange this to find the time. First we bring it up, and we have velocity times distance is equal to velocity times time is equal to the distance, and finally we can do time is equal to distance divided by velocity. Now, out of these two, we've got the distance, so we are missing this guy here, the velocity, right? How are we going to find the velocity? Well, we know that the power is equal to the force times the velocity. They give us the power, we only need to know the force now. So if we want to know the velocity, let's rearrange. It would be P over F. Okay, and we need to know the force because we already have the power. What's the force? Same thing as we said before. If it's going to move at a constant velocity, then if the weight is 300 g, so is the force going to have to be also 300 g. So from there we can get our velocity, and then from here we can get our time. Does that make sense? See if we can finish off commenting on the next one. This is for part A. So let's see, for part B. What are we doing for? Got about 1 minute and something left. You can finish 4. How much chemical energy is converted by the motor during the lift if its efficiency is 20%? Okay, so if its efficiency is 20%, then this is how much power the thing is actually outputting, right? But if the efficiency is 20%, it means that 800 watts is equal to 20%. So what they're asking you in part B is actually how much chemical energy is converting, then how much is 100% if 20% is 800. Okay, so read the question properly, because it says how much chemical energy is converted by the motor during the whole lift, so during all the time that it lifts it up. So if we do this in watts, then we're going to, if we convert from 20% to 100%, we're going to know how many watts it does per second. But then we need to use the time from the part A to multiply it by that to get the total number of joules that it's done during the whole lifting. So how do we go from 20 to 100? Well, we can multiply by 5, because 20 times 5 is 100. You could do it like that. Or a method that works generally is that if 800 is 20%, then you can divide the 800 divided by 20 and you get 1%. Then you multiply by 100 and you get the full thing. So it works out to being 4,000 joules, sorry, 4,000 watts.